Hi, and welcome to Maths Appeal. I'm Bobby Seagull.
And I'm Susan Okereke.
We're both maths teachers, and we want everyone to love the subject as much as we do. But we know that from experience that it's not always the case.
Our aim for this podcast is to show people how engaging and accessible maths can be. So if you didn't enjoy maths at school, or you're currently studying it and find it frustrating, stick with us for this next half hour, and we can hopefully share our love of the subject with you.
If you want to find out more about us and our maths stories, or find some useful maths learning resources, find us on Twitter or Instagram. We're at Maths Appeal.
And here's what to expect from the podcast.
So Susan and I discuss a topic. Today it's the language of algebra. And then I said a puzzle related to it.
While you're working out the puzzle, there's an interview with a fellow maths fan, and today it's comedian Ken Cheng, who's got an incredible maths story.
And then we go back to the puzzle and chat about how we tackled it.
And then we finish off with a maths fact.
But before we get going, Susan, me and producer Jenny just want to say a huge thank you for taking the time to download this podcast.
Thank you.
We really appreciate your support to help spread the word. So please tell your friends about Maths Appeal, or give us a nice rating, 5-star.
5-star, please. Right, so let's get into the language of algebra. The way this section is generally split up is we have 3 questions that Bobby and I talk about and discuss as maths teachers. First question is, what do we feel, what do we think about when we first hear this topic? So when we think about the language of algebra. The second question is, how do we teach this topic? And then the third question we kind of discuss is, what are the common issues that arise when we teach the subject? So do you want to maybe start talking about what algebra is, Bobby?
Yes, so actually when people heard the word algebra, their reaction is one of, oh God, a lot of people, they start getting their heart rate rising, sweat beads dropping off their forehead. But I think algebra is like one of those misunderstood topics. And in terms of what it is, it's all about finding the unknown. It's almost like a treasure hunt. You know, in treasure hunts, you're trying to find the hidden cross. And in maths, that hidden cross is usually an X. So for me, it's about trying to solve for an unknown variable, normally X, but it could be any other letter, and you're working with formulas to try and rearrange and ultimately work out what this X is. That's sort of what algebra is at school level anyway.
Yeah, I think kind of a lot of people think algebra are letters when it comes replacing numbers, and a lot of people don't understand that actually it's kind of a language that you just have to become quite fluent at, and when you are, it's quite fun. So I've found as a teacher that either people hate it and they don't get it and they get really annoyed by it, or people love it. As in, you know, like when you know how to do something and you just love the procedure, people kind of get into that. And I love teaching it because I think the whole idea of decoding it when people understand what it means is such a wonderful feeling, because people can go from not getting it to just making pages and pages and pages of working out, which they really enjoy doing.
So do you think it's almost like a microcosm or a magnifying glass on the whole relationship with mathematics? You know, we talk about people either love or hate maths. Is algebra, does it like almost represent the best and worst qualities of maths to the public?
That's a good way of thinking about it. Because I think for me, the whole idea of algebra and maths, but like specifically algebra, is the fact that it's like learning a language. You know, it really is very much like, you know, I remember at school learning French, and, you know, you'd have to learn how the different letters sounded. You'd have to learn what the different verbs were, what different endings are. And I think if you don't understand what those things are, putting together a sentence or understand what people are saying is really tough. So one of the things when it comes to starting to teach the subject, whatever, like, you know, in a scheme of work, which is the list of topics and the order you do them as a teacher, if they suddenly say, oh, you've got to do like solving equations, I'd always start with the basics of, do you understand what the term, say 3x, do you know what that means? And if you don't know what it means, there's no point in trying the problem. And actually, the basics of understanding what algebra notation is essential to be able to try to work out the things in the questions. So it's things like knowing that in algebra you have the letter A and the letter B together. That means A times B, because multiplication, you don't put it into the form for notation. You don't kind of, when things are multiplied together, they're just effectively all put together. So 2 times y would be 2y. And that's what that means. So a lot of people get really confused by that as an idea. And then division is generally written in fraction form. So x over 2 means x divided by 2. If you don't understand what those things are, when you look at them, it looks like it can be incredibly confusing.
Yeah, so students have got to be quite comfortable with a lot of the operations of mathematics. You know, we talk about things like BODMAS or BIDMAS, that's like brackets, indices, division, multiplication, addition, subtraction. If students aren't comfortable with those operations that they tend to learn in primary school, algebra is another level up, because you start introducing those same concepts, but this time with letters and symbols.
And also understand the reason why you're doing it. So the whole idea of BIDMAS or BODMAS is telling you the order that you're meant to do parts of a calculation. So you need to know that to then be able to, if you throw in algebra, know what the order that you're doing is in. So it's kind of, if you've got any misconceptions or any gaps, algebra in your number work especially,
does it multiply it?
It makes it so much worse. Yeah. So if you don't understand, when you're subtracting something, if I said to you 23 take away 5, and you understand that 23 is the first number where you start, and then take away you're removing 5.
Yeah.
If you don't understand that, you're not going to understand 3x take away 5 as well.
So algebra is like a magnifying glass. It really shows the cracks in your understanding, or it shows that you really got a smooth foundation of your
understanding.
Yeah,
and also it can be incredibly satisfying when you understand the order of how things work, because actually algebra is just an extension of number, because the rules are the same. So and that's kind of where having a good understanding can really help with someone's development kind of further. So I think some of the things I think about when I'm teaching this subject, one is making sure the basic notation, how do you write things? What do how do you write things in algebra? What do the certain things mean? What do these symbols mean? Understanding that x squared is x times x. And that means
not 2 times x.
Not 2 times x.
That's a really common misconception.
And understanding as well the fact that x could be any number. So you could have x is equal to 3, you substitute that in, that'd be 3 squared. You could have x is equal to 10, which is 10 squared.
Yeah.
And it's understanding that. But also it's understanding the different language used for it. So for me, the key ones when it comes to teaching them is understanding what simplifying is, collecting like terms.
Yeah, that's such an important thing. So collecting like terms is when we've got, let's say, lots of x's and lots of y's, and we're putting all the x's together and all the y's together.
So it's like tidying up an expression.
Yeah.
So if you've got something like 3x plus 2y plus 3x plus 2y, you can put all your x's together, which is 6x.
Yeah. But
then another thing that the student needs to be aware of is the fact that, so that's simplifying, collecting like terms, but you can also substitute. And substituting is where you have a number that you then put into an expression. So, as I said before, 3x means 3 times x, but then that you could be told that x is equal to 5. So that would be 5 times 3.
Or x equals minus 5.
Which would be 3 times minus 5. Mm-hmm. So it's that whole idea of understanding what the question is asking you to do. And then another thing as well is solving. So that's when you're
the final part.
That's the final bit where you're actually trying to find out what the unknown is. And these are they're different operations, they're different things to do, but a lot of people see them as the same. And that's why I think a lot of people get confused with algebra and they think it's one thing. But actually, there's different procedures for different things. So you might be wanting to tidy up your expression. You might be wanting to substitute number values into expression. Or you might be wanting to find out what the unknown is in your expression. And they're different things. And knowing that makes it possible to be able to work it out.
Yeah, and ultimately most questions at school level, especially for algebra, you're trying to solve for an unknown. So you could have an equation like 2x plus 3y equals something. Or it could be in a worded form. You've got 2 eggs and 3 yogurts and they cost this amount. And you're trying to decipher that and write it into the language of algebra to make it a bit easier.
I mean, that's exactly it. I think in school it's used quite a lot. I think a lot of people suddenly kind of go, well, what is the point? And that's where it kind of becomes a little bit harder because it's used in loads of things regarding like algorithms for working unknowns out. But actually, most people day to day...
We don't practically need to sit down and write 2x plus 3y equals...
No. But then understanding it, it's almost like... being able to do it is quite useful because it sort of teaches you to be quite methodical.
It does.
You kind of have to be organised in your thought process to be able to solve for algebra. You need to be able to be quite methodical and notice things to be able to simplify algebra. It's a way of thinking that can be quite helpful beyond your schooling and into the real world.
Yeah, even if you're studying physics or engineering, the laws of nature of falling, so gravity or how planets orbit each other or the projectile of a cannonball that's all using algebra underneath it.
What's funny, I didn't actually do like mechanics or physics, so my kind of knowledge of that is quite bad actually. But the satisfaction I got, I love teaching it. I love teaching it. I love doing it because I like the process of steps. So you like have a first step, you have a second one, you have to be clear about what you've done. And you need to be able to, as you do it, communicate that with whoever's looking at it. So my thing as a pure mathematician, if that's what I'd be called, is just the satisfaction of like having a problem and with algebra, working it out on a page. It looks very nice. And I'm like, I've accomplished something today. But I suppose it is true. A lot of the time, algebra can be used in a really, really, in real life, in a really practical sense, in a variety of different jobs.
And when you get that final aha, x equals 5, let's say.
Yeah,
that's the joy of maths for me.
Right, so I hopefully that's been kind of useful for people and it's demystified some of the algebra worries that people have. We'll be sharing some of the points that we've been talking about visually, Maths Appeal on Twitter and on our Instagram. But I think now it's time for a puzzle from Bobby.
My favourite part of the week. Okay, so this week, let's take a flight across the Atlantic to the United States. We're going to visit the White House. So we're looking at a couple of previous residents from the White House. So the former First Lady of the United States, or the FLOTUS, F-L-O-T-U-S, Michelle Obama, is 3 times as old as her youngest daughter, Sasha. 4 years from now, the sum of their ages will be 80. So your puzzle is, how old are Michelle and Sasha? And this is a quick warning to our listener. Don't Google this because I've slightly adjusted the ages to make it fit a mathematical puzzle.
Right, so we're doing this puzzle because algebra will make this a lot easier, right?
Yes.
So, okay.
Do you want me to say it again?
That'd be great. So we're trying to work out, like, what are we actually trying to find out and what information are we given? So, yeah, one more time.
Yeah, so Michelle Obama is 3 times as old as her youngest daughter, Sasha.
Sure.
4 years from now, the sum or total of their ages will be 80.
Right.
So how old are Michelle and Sasha?
Okay, right, I've got that down. I'm going to start thinking about that now. So while you're working that out, let's hear from the comedian Ken Cheng. He's currently on tour across the UK with his show Best Dad Ever. And I spoke to him recently to find out about this show and to find out about his math story. It's incredibly interesting.
Hi, my name's Ken Cheng and I am a stand-up comedian as well as a professional poker player, and also I dropped out of Cambridge University when I was studying maths.
Oh, brilliant. Well, this is quite a varied existence. It's amazing.
Yeah, a lot of different bases there.
I just want to hear a little bit about how you found maths at school.
School was, that was when maths, I was very good at maths when I was very young, I think. I think I was taught maths by my dad, like arithmetic, like I could do, like, I knew my times tables before anyone in my school, and stuff like long division. My dad taught me that. I used to just love practicing that on my own before it was even introduced in school. So when they introduced it, it's like, oh great, I've done this.
How old are you?
I don't know, like 3 to 5, like just kind of very young, I remember getting to it very young, and then I was always good at maths. It was always my thing. It was always like, oh, that's the subject he's good at. And then A-levels was where it was all very smooth in A-levels because I would just understand all of it quite easily, and I would get mostly 100% on the papers, like even the like further pure ones. So that was always fine for me.
You're gifted, okay, right? And so then, so you decided to go to Cambridge to do maths. Okay, and how did you find that? That
was a complete new world because I went from understanding everything to understanding almost nothing. It was, I struggled a lot in Cambridge. Yeah, I remember, it's a very specific thing, Cambridge maths. It's not like how you learn maths in school in sixth form. It's very different. You're almost learning a completely different subject, really.
In what way? What was it?
So like in A-level, you learn the concept and you learn the method that you apply to whatever question that you get, and you just do that repeatedly until you're competent with it. And then in uni, the questions are all like, you don't know what you're meant to do to start with. So like you'll get a question, you have to work out what what method you're meant to do. It's almost like a puzzle, like when you get one of those maths puzzles where you don't know how, like what's a good example, like the one where there's loads of triangles on a piece of paper and you have to count the triangles.
And you don't know, there's almost infinite number of triangles, there's so many, you don't know where to begin.
You don't know what maths concept, but there is a maths concept you could probably do to make it easier.
But you don't know what it is
You don't know what it is yet, and you have to work that out. And it makes it even harder when you also don't understand all the concepts that you learn. The way lectures were taught was very difficult for me, because in school it's quite interactive. You get asked questions by the teacher, but because you're in a lecture hall with, I think, 200 people, they don't have that. It's just a person, a lecturer, basically, just writing and talking for an hour straight, and you don't have any breathing time. You just have to try and take that in, and if you get lost at any point, you're done. You're behind. Yeah.
So obviously you found it a bit challenging. It was a challenging thing to do.
Yeah.
How did you then turn to poker?
I was playing poker already in school in sixth form, and that was my passion already going to uni. So that didn't help. Right. So I was demotivated by the maths, and I just wanted to play poker. Did you use much maths in your poker? There is maths. There's a certain amount of maths to work out, like probabilities and stuff, but also it's more that it's quite a mathsy brain thing to play poker. I think all strategy games are. There's an element of maths which isn't like arithmetic or any specific mathematical
problem solving.
Yeah, it's logic, and it's decision making using a kind of understanding of like game, a kind of basic understanding of game theory and all that. And yeah,
so it was something that really kind of inspired you a bit, or kind of got you quite excited, which wasn't happening.
Yeah, exactly. I think that's the problem with the kind of abstractness of a lot of maths, is that it's not that applicable, and then when you find a way to kind of apply a skill, you're like excited about that.
So then from poker playing to comedy, how did you make this happen?
I was always very shy before I started comedy, and I never thought I would be the person who would start. And then suddenly I just signed up for a gig. I just decided...
Sorry, you've not done a gig before, and then you just signed up for one?
Yeah, I just signed up. I was at a gig, and they were like, oh yeah, if you want to perform, just sign up, put your email down, and I just decided to. And before that, I never imagined myself being on stage.
Did you have a routine?
I wrote a routine in the month up to that.
Oh wow! Okay, so you had your end goal and you made it happen at that time, right? Yeah,
and before that I was never a public speaker or anything, and I was never. And a lot of comedians want to be a comedian when they're a teenager. I think I'm not like that. I was never interested in it, and just suddenly I've discovered it, and
wow,
there we go.
And it was based on the fact that you'd seen people, you'd gone to comedy shows and thought, actually, I'm going to try this out.
Yeah. My friends thought I was funny as well. That helped. I think I was known to be funny at times, so that was always good.
Works for you so far.
Yeah, it's gone okay.
So tell us then a little bit about the content, this type of stuff you kind of talk about for people maybe who've not heard of you.
So yeah, it kind of varies. I think the maths side does come in a bit. I do some graph stuff. Occasionally I use PowerPoint and the graph stuff, but also I'm quite logical. I think I'm quite analytical in that way, that kind of appeals to the sciencey brain.
But also you can be quite controversial sometimes as well, can't you? Which is quite entertaining.
I'm less controversial now than I think I was before. I think I've become less. I used to be more, but now I've kind of, especially as I had a radio series just out, and I think you have to kind of avoid controversy.
Okay,
so a lot there.
But some of your Twitter comments have been quite entertaining.
Yeah,
close to the bone.
Nice. Yeah, no, you can still do that on social media, which is fine. But yeah, I think there's a thing about mathematicians, kind of, and joke writing. The art of like specifically joke writing, not all of comedy, but joke writing is quite a mathsy thing, and there's like a certain breed of kind of like ex-engineers, doctors, scientists who get into comedy because that's actually quite a mechanical thing. It's quite not formulaic, but there is an element of that where you're putting together like some kind of problem,
and then sort of seeing what the outcome is.
And then kind of tinkering with it, bits and bobs, and kind of putting different pieces from different things into it, and
like the maths and comedy.
Yeah. There are definitely a few few like sciencey people who go into it.
And so tell us then about your new tour. Tell us about that.
Yeah. My new tour is my previous Edinburgh show. It's called Best Dad Ever. It's a departure from my first show, and that's a storytelling show. I'm really going to stories from my upbringing and my family. I think I grew up here, but my parents are from China, so it's quite there's a culture clash there. But there's also a lot of dark secrets about my family that come out in the show. So it's about that.
And so and also you're doing some stuff on television. What kind of things are you going to do?
Yeah, so I've got this show out. I'm co-hosting this. I guess it's a game show. It's not like a quiz show. It's like more like they play physical games. It's
physical games, as in what type of thing?
Physical challenges. I'll try and think of an example. It's called the Hangover Games, right? So essentially, the idea is all the contestants are very hungover when they're playing it.
Are they actually hungover?
They're probably hungover. God! And they don't even know they're going to go on it. They get woken up and they get brought into the studio and they have to play these games, which essentially are the things that you wouldn't want to do when you're hungover.
Brilliant. Just tell us a little bit then about the maths that you love. So you obviously kind of enjoyed it before you sort of did it at university.
Yeah.
Like what kind of really kind of made you happy as you did it?
Ooh.
Your favourite topic?
My favourite topic of maths, it takes me back. I get a probability, which comes out in poker, is probably the one, because I think that one you can kind of, once you have a gauge on probability, you realise, oh, this is so useful in the world, because people don't inherently understand probability very well.
Yeah.
And that's always cool to get a hand on that. And that comes up the most in not just poker, but almost any decision that you make. Like even in comedy, there's a probability of what joke will go well and stuff like that.
Wow. Okay, thank you.
Thanks for having me.
That's been wonderful. Thanks so much.
And that was Ken Cheng, who's currently on tour with his show Best Dad Ever, going to loads of places like Swindon, York, Leicester, Colchester, Manchester, Bristol, Peterborough and Maidenhead. And we'll tweet a link to his tour dates later on. Speaking of Twitter, Susan, you mentioned that some of his posts could be a bit close to the bone. What did you mean?
I think he's got a real knack for being controversial, with the view, I think, to get people thinking, but also to stir up some like mischief. And like, for example, he did a post on Twitter that disrespected every single flag of a country. Which he's very clever, but I think there's a lot of people who kind of didn't appreciate it. It's kind of, he notices a lot of stuff and highlights it, and it's quite funny, but also you're a bit like, you can't say that though, and you just have.
So using his like observational powers, almost like he talked about his like analysis and the things that he was good at school.
Yeah. I saw his show at Edinburgh, and it was really, really clever. He does a bit with like PowerPoints, talks you through stuff, and it's just, very logical. And then the punchline is generally quite funny because you're like, very clever, very clever. Which is, great thinking about the fact as well that, there's the maths behind joke writing. There's what you lead stuff up, there's a logic to it.
It's almost like a formula for...
Yeah, which I think is really interesting. I've never have thought. You see, math literally is everywhere, guys. It's in comedy,
The comment actually he talked about that I found particularly interesting was about how he found maths at university when he was at Cambridge very different to school maths.
Yeah.
And I think this is an interesting point for our listeners, because a lot of people who say, I couldn't do maths, I hated maths, they're actually talking about school maths. And I think school maths is definitely something that we can get better through effort, because school maths generally, there's with algebra or probability or shape and space, there are methods that you can learn, and an exam or a real life type situation, there's a way of going ahead with the problem. But I think at university maths, it starts to become a bit more like abstract. And then, it's harder to say there's a real life application of analysis in university maths or advanced mechanics. Like they're things which are much more abstract, harder for people in everyday life to get to grips with. Whereas school maths, I think what he was talking about, it really clicked because it's about numeracy and arithmetic.
But then it was interesting talking to him. I had a little chat with him after the interview and stuff. And, having done a degree in maths myself, like we kind of bonded on some level about the challenge of the degree maths. And then it really kind of for me, it helped me as a teacher understand that feeling that students might have when you're learning something new and you just don't get it. And like there were times I remember being in lectures and he talked about it as well, that you'd be in a lecture and you're like, I have no idea what this person's talking about, which is tough, especially if you're used to getting things right, or if you kind of, if you're used to getting things right, or if you think you should be able to do it and you can't. It's an incredibly frustrating thing. And I think delivery is actually quite important, and engagement also is really important. So,
Do you think, so in our lessons, when we teach our kids, let's say we introduce algebra for the first time to a year 7 class, like there'll obviously be students in our class that are just going, I have no idea what Miss is saying. I literally have no idea in their head.
But I think that's one of the things about like school is ideally it should be a space that introduces everyone to something in a way that everyone can access. And that's incredibly difficult because that's everyone in this country has to go through the school process. But I think a lot of teachers acknowledging the fact that students can and do find things difficult. They might be because they're talking, but it might also be because of the way you've explained it. It means that there should probably be a way of like rethinking how you deliver something. And I think with Ken sort of speaking about his time at university, one, he kind of acknowledged the fact that he might have been a bit distracted with the poker, but I think also the way it was delivered to him, who's obviously capable.
Of course, yeah.
He'd got into Cambridge to do maths. He obviously did well to be able to do it, but then that hurdle of the way it was delivered to him didn't fit, and so he then doesn't do it anymore or didn't engage with it. So it's kind of knowing that people could be capable. It's highly likely that he would have been able to finish if he'd engaged with it.
Yeah.
Or maybe it'd been delivered to him in a different way. And actually, as teachers, our thing is hard, definitely a very difficult thing, but our thing kind of should be to make maths as accessible to as many people as possible. So if someone finds it difficult, trying to work out why that is, and then, changing kind of how we do that to help them in. But as I say, that's in the ideal world. I know that's difficult, but for schools, it should be our aim.
Exactly. So if one approach doesn't work, try another method. Because in a dream world, you'd like to think if I teach it one particular way, everyone will understand it. But actually, people's brains sometimes need different ways or a bit longer to understand things.
Yeah. And I suppose, and again, that takes time. Thanks again to Ken for being such a wonderful guest on Maths Appeal. And he mentioned that his favourite math subject is probability, which is actually our main topic for next week's episode, which is wonderful. And let's go back to the puzzle now. So, Bobby, can you please remind us of what your puzzle is?
Okay, so we're in the United States. We're with the former First Lady. So, Michelle Obama is 3 times as old as her youngest daughter, Sasha. 4 years from now, the sum of their ages will be 80. So your question was, how old are Michelle and Sasha? And warning, don't Google, because the actual ages are slightly different.
Oh, right. So let's think about how we did this. I have to say, I think Michelle Obama is a dude.
Oh, yeah, she's amazing.
She's amazing. Yeah. But yeah, no fangirl. Right, so let's think about her age now. I used algebra for this because obviously our episode's about algebra.
I know, that was a good... I know. So, we should do another series where we do puzzles and people have got to work out what episode it will fit in.
Oh, yeah. Let's kind of get them to think across our episodes. Yeah. All right, so from what you said, Michelle's age is 3 times Sasha's. So I put Sasha's age as X, or unknown. So I used X. And then I knew that Michelle's age is 3X. And that's today. That's at today, if we were to go from today. So Sasha is X, Michelle is 3X.
Good.
Then in 4 years' time, Sasha's age would be X plus 4. So whatever age she is added on 4 years. And Michelle's age would be 3X plus 4. So whatever she was today, 4 years' time, we just added on 4.
Good.
So then I put them all together, where I added X plus 4, which is Sasha's age, plus 3X plus 4, which is Michelle's age. And altogether that equals 80. So I created an equation with those on either side. I then simplified one side, the one with the x's, and I collected them, the x's and the numbers together. So I got 4x plus 8 equals 80. Then I kind of rearranged it a bit and I sort of took 8 away from both sides, and I ended up getting 4x is equal to 72, and then divided that by 4, and x is equal to 18. So Sasha's age today is 18, and then Michelle's age is 3 times that, which is 54.
Perfect. So there's 2 methods I have so far. Again, our listeners may have other ones.
Yeah.
So I think the one that you went for was picking one variable.
Right,
So you just, everything centered around an unknown X. A second method I had was where we say Michelle equals 3 lots of Sasha. So essentially M equals 3S.
Okay.
And then what we say is in 4 years' time, it will be Michelle plus 4, M plus 4, plus Sasha plus 4
Yeah.
equals 80. And then when you simplify that, you get M plus S equals 72. So now we've got 2 equations. Michelle equals 3 lots of Sasha, M equals 3S, and Michelle plus Sasha
Equals
72.
72, yeah.
And then
sorry.
if you the M equals 3S, Michelle equals 3 lots of Sasha, you put that into that M plus S equals 72.
Substitute it in.
Yeah, so we get 3S plus S equals 72, then 4S equals 72, and then we're back to where you are.
Oh, right.
So just a different approach to get the same weight.
So we're going to, again, our solutions we're going to make available on our Twitter and Instagram. I didn't think to do it your way at all, Bobby. I love that. And will be images of those. And we'd love to hear how you did. If you did it differently, if you used a different method, please share at Maths Appeal. Before we go, how about one final bit of maths trivia? Bobby, have you got anything from your book, The Life-Changing Magic of Numbers, available now in all good bookshops?
Good bookshops for good books. Well, again, this week we've got almost like my bloopers, best outtakes. So this is one that made I'm going to have a separate book of all the
B-sides.
Yeah, the B-sides, yeah. So this is about, so imagine, let's get in a time machine, yeah? Like maybe a DeLorean.
Sure, lovely.
Let's get to 11 times 8.
88.
88 miles an hour.
Hey!
And we're going back to the early 9th century in Baghdad. You were there, yeah? Can you imagine you're in Baghdad?
I can feel it, yeah. I can feel it, yeah.
So you're now meeting a man. His name is Al-Khwarizmi. And he's written a book called Kitab Algebra wal Al-Muqabla.
Lovely, well said.
Lovely. And that's what this means is rules of reintegration and reduction. And this book actually was so notable it found its way into Europe and became the first textbook on algebra in Europe.
Oh, wow.
And the Europeans used part of that book title, Kitab Algebra, and Algebra actually just means reunion of broken parts. And that's where the word algebra comes from.
Oh, wow.
Yeah.
Wow. That's really great. So it was a guy who wrote a textbook
around Baghdad in early 800s.
Oh, fantastic. Thank you. What's his name?
His name was Al-Khwarizmi.
Thank you, Al-Khwarizmi. Thank you for bringing algebra to us.
Yeah.
And if you want to send us a maths fact, please get in touch. We're at Maths Appeal on Twitter and Instagram.
Yeah, we'd love to hear from you. Thanks again for downloading this podcast. Our guest next week is a science writer, Simon Singh. I'm a huge fan of his. I love his books, particularly the one about the maths and the Simpsons. So I'm really looking forward to hearing what he had to say to you, Susan, about maths education.
He was great. He's doing loads of incredible maths education projects. And he told us about loads of fun maths apps and games and learning resources, which I've never heard of. And it'll be really worth a listen.
So we'll hear you next week. You've been listening to Maths Appeal with me, Bobby Seagull, and Susan Okereke.
And the music was composed by Kelly Okereke, the image design by Calix Davis, and the producer is our wonderful Jennifer Nelson.